How's it going, everybody? In this video, we're going to take a look at some IPv4 addressing. So we're going to take a look at some high-level details of an IPv4 address, the structure of it real quick, just in case some of you haven't studied for the CCNA in a while and are like, I don't remember a lot, Rob. Can you help me out? I got you covered. So let's go ahead and dive into some examples of subnetting. So let's go ahead and pull this bad boy out. What we're going to start with is just the overview of some basic stuff. So normally I dive right into, the bits and the bytes and all that type of stuff, but I want to start out with talking about the classes. So you're going to have Class A, Class B, and Class C. What this means is you have different class ranges. So we're going to start off with 1.0.0.0/8 through 126.255.255.255/32. Okay. Class B is going to be 128.0.0.0/12, or in this case here would be /16 actually, and then through 191.0.255.255.255/32, but that's supposed to be a 5 right there. Then lastly, we have Class C. There's technically D and E as well, but we're not going to dive into them. Class C is going to be the 192.1.0.0.0 through, this will be a slash, technically this is /12, but we'll do that as well. And then here we'll have /16 through 223.0.255.255.255/32. Now, I don't want to spend a ton of time in these ranges. These are the classful ranges. So if you see a 121.16.33.0/24, know that this is a Class A address. If you see a 145.21.63.0/24, Class B. If you see a 190, let's do a 201.27.171.0/24, this is the Class C address. Okay, just to give you some context to how that would come into be. Now, the reason why I'm breaking it down like this initially is so that you will understand subnets down the road. When we take a look at the /24 piece of it right here, this pretty much means how big the subnet is actually going to be. /24 means that the first 24 bits of an IPv4 address must be the same in order for you to be able to communicate with another device in that same subnet. Meaning, if I have 201.27.171.13 and I also have .44, for example, then these two will be able to communicate, because if you look at a 201.27.171.44 and .13 with a /24 subnet mask, so 255.255.255.0, these bits right here, from here to here, as well as everything in between, these must match. So 255, 255, 255 means that the first, second, and third octets must match in order for them to be able to communicate with each other. In the fourth octet right here, this can be any other IP address. So it could be 13, it could be a 44, does not matter. It just needs to line up. And when we talk about this, this is where the binary ANDing comes into play. Because if I have a bunch of /24s and I have, let's say we take the 201.27 again. We take 201.28.171.0/24. What's going to end up happening is this IP address right here is going to be a different binary value than 27 is going to be. So if I take 201.27.171.0/24, these are two different subnets. The reason we know that they're two different subnets is because when you look at the most bits in common, or what bits line up and what bits do not line up, you'll notice that in this particular portion here, in the second octet, they don't line up. Now, you might be asking, how do you know that they don't line up? Well, you have to understand binary. So let's actually take a look at how that would come into play. Let's take a look at how 28 is viewed by a router, switch, or a PC in binary. So the first thing we have to do is we have to write out the numerical values for them. So we'll start off with the 128, 64, 32, 16, 8, 4, 2, and a 1. Okay? Now, depending on which one of these bits is turned on, so every one of these is a single bit turned up. So we have 1, 2, 3, 4, 5, 6, 7, 8 bits, right? And you count them. This is the high order bit. This is the low order bit. Okay, let's get the smallest number. When I take 28, for example, what I do is I'm going to selectively turn on and off bits in order to make 28 become 28 and 27 become 27. So if I take 28, for example, I'm going to turn off these bits right here, 128, 64, and 32. I will turn on 16. If I go to 8, 16 and 8 is 24, so I'm going to turn this bit on as well. If I do 4, so 16 and 8 is 24, plus 4 is 28, so I'm going to turn this bit on as well. If I added 2 more, that would make it a 30, so I have to turn this one off, and I have to turn this one off. This is right here how you make 28 in binary, 0, 0, 0, 1, 1, 1, 0, 0. For 27, it's the same concept, 0, 0, 0. I turn this bit on, I turn this bit on, I turn this bit off, I turn this bit on, and I turn this bit on. So I've got 16 and 8 is 24, 24 plus 2 is 26, plus 1 is 27. So as you can see, the determining factor here is these bits are both different, right? So because I know that they're different, when I do an ANDing, I compare this in binary to this in binary, which is going to be this and this. They are different. Therefore, because they are different, means I'm going to know that there's two different subnets. That's how I'm going to determine that. Because you could have both subnets running in the same VLAN, the same broadcast domain. But if I was to try to get 201.27.171.33 and 201.27.171.37 to try to communicate with each other, as long as it's /24 subnet masks on both of them, we'll just throw that in there, they will be able to communicate with each other. But if you take and you apply 201.28.171.33 and you took 201.28.171.37 and allowed them to communicate, they would be able to communicate all day long, no problem, because they are in the same subnet. But if I wanted to communicate between 33 and 37 here, this would not work, because when you compare the second octet right here and you do the binary ANDing right up here, they will not match. Therefore, they will be dropped, because when some sort of packet goes out from one device to the other and they start decapsulating the information, they go, oh, well, my IP addressing doesn't line up with your IP addressing, so therefore you must be in a different subnet. In order for these subnets to work, like here, I would need to route them to some sort of layer 3 device this way, so that they could send and receive traffic between each other. So they would need to be routed between some sort of layer 3 device, whether it's a router on a stick, a layer 3 switch, whatever the case might be, that would need to be taken care of. And that's where this really comes into play. If you understand how all of that plays out, that's really the glue that locks all this stuff together. So now that we've taken a look at how that comes into play, let's take a look at a different example, because now we've determine how subnets are different from each other, right? Let's go out and take a look at how the binary piece comes into play and how you figure out how to determine subnets. What are the ranges and things like that. So we're going to take the same logic again, that 128.64. Let me draw that a little bit cleaner here. 64, 32, 16, 8, 4, 2, 1. Now what I want to do is, again, this is the high order, this is the low order, and each one of these is a single bit, I should say, right? They are a single bit, and they can be turned on and off as you need to. So let's say, for example, we want to take something like a /24. We're going to take 10.1.1.0/24, and you need to break this up into a couple of different smaller subnets to allocate to a single branch office. So you've been given a branch office to deploy, you have a single /24 for the internal routing to be used, and you need to go ahead and allow that. Now, before you can really do that, you need to figure out, okay, out of this /24, how many actual IP addresses do I get? Now, you may not know the answer to that, and that's okay if you don't. I'm going to tell you so that it's easier for you to understand. But basically, a /24, in terms of the operations, you are going to have basically right around 256 IPs. Okay, now there's going to be a few IP addresses you're not going to be able to use. The very first one that you're not going to be able to use is going to be the network ID, or 0, right? You can't use 0 in this case, and you can't use 255. Okay, so that automatically deducts 2 from the total. So actually, let's do it this way. Let's do 0, 255, right? So you're going to deduct 2, which leaves you 254 IPs. Okay, so you can't use the network ID and you can't use the broadcast IP address for this particular subnet. There's one other IP that you cannot deploy. You need one other IP address to allocate as the default gateway. Anything 1 through 254 are valid IPs. So for the sake of argument, we're going to say you are going to allocate 1 in this case, right? So now you subtract one more. So minus 1 equals 253 IPs. So that's what you have left to allocate. Now the way you break this down is you need to basically know how many devices will be used per subnet. What they're actually going to be used for, we really don't care at this point. We just need to know, okay, how many total IPs do I need to allocate per use case? So whether it's servers, whether it's wireless, whether it's phones, whether it's DHCP pool for your users, we don't really care at this point, right? We just need to know how many IPs need to be allocated. Now you might say, well, why does that matter? Well, that matters because these values up here are going to basically be that value. So let me give you an example. If I come to you and I say, let's say your name is Roger, and I say, okay, Roger, what I need you to do is I need you to allocate, we know 253 is our total, right? So we can start deducting 2 from whatever value we choose here from this value right here, right? So we're going to deduct a certain amount. So the rule of thumb here, in case you didn't know this already, is you always start at the biggest subnet and then you whittle your way down to the smallest subnet. The reason why you do that is because you're going to have the greatest usage of the entire address space as you can. You don't want to start with the small stuff first and then grow to much larger, because you can't just take an IP address randomly, right? You can't just grab, say for example, 74.74 is the IP. You can't just grab that IP and allocate it, because that .74 is going to be a member of a certain subnet range. Now by default out of the gate, it's part of the total, the 253. But if you grab just a random IP out of that subnet and allocate it, then you need to make sure that whichever subnet that .74 came out of, after you've done subnetting, that you apply the appropriate variables to that. So what that means is I need to figure out how many device IP addresses again are going to be used. So again, you always go from the bigger number to the lower number. Okay, so you always subnet this way. Okay, now let's give a couple of examples. So we're going to say, let's do a couple big ones first, right? So we're going to have, for example, let's say 55 users. Okay, 55 users, a 55 user subnet. We're going to have another one that's going to be 53 users. Okay, great. Then so that's a total of 108 IPs. Okay, but we don't really care about this specific number. I'll explain how this comes into play here in just a moment. You take these numbers right here. Are you keeping track of how many IPs? You are, but just remember that for every one IP, you're going to be deducting from the total amount. Okay, so we got 55 and 53, so it's about 108, but 108 isn't the total capacity that we're going to be able to allocate. Then we're going to have a couple of smaller subnets. Let's say we have 21 for something else, and then I'm going to go ahead and get out of the way, and then we're going to say 21 again, and then let's say 16, and then we're going to say 6, just to give it some interesting numbers. Okay, now the way that you do this is you look at this number here, you look at all of them individually, right? And then you look over here and you say, okay, where does this number fall in between? Does it fall in between here and here for the first one? No, it doesn't, because in order to allow for this number of users or this number of IPs to get allocated, you would need this range and this range again in order for that to work, and that doesn't apply. The way you want to look at this is, how many IPs do I need to allocate in order to meet this number without going over? So if I chose this one, this would not be enough. 32, I would need another 32 in order to meet the 55, right? Because even if I was to add 16, that wouldn't work because that's only 48. So what I do instead is I come over here to 64. It's more IPs than I need, but it does give me a little bit of wiggle room. So what I do is I say, okay, 55 users, then I know I'm going to go here to 64. So I'm going to put here, let's say this is 1, 2, 3, 4, 5, 6. Okay, I need 6 total subnets. So I'm going to put here 1, right? And then the second one here is 53. So obviously I'm going to have to come over here and do the second subnet's going to be over here. The third one is 21, right? So 21, we look through here. Well, 16 is not big enough. 32 is too big. But 32 is bigger than 16, which gives us more than what we need over here. So I'm going to put down here 3 and then 4 because they're the same value. And then if I look here at 16, well, 16 falls right here. So you're thinking like, boom, that was easy, right? Well, you can't actually use this because you won't actually be able to give it 16 IPs, because remember this rule up here. You can't give the network ID, you can't give the broadcast, and you cannot give, you need to allocate one IP from that range as the default gateway. So now we are back to the 32 again. So for number 5, we had to put underneath the 32. And then for this last one, we have 6. We look at 6 and we're like, oh, well, that would fall underneath 8. But again, that won't work because you have to take into consider the network ID, the broadcast domain. That automatically brings you down to 6 right there, plus the default gateway. Now you're down to 5 usable. That's not enough to meet this need, so I need to go to 16. So this one here, I put 6. Okay. Now, what's going to end up happening is, for the first one, is for the subnet mask, I need to take this value and this value right here, and I need to turn them both on for 1. So for 1, I'm going to go ahead, I'm actually going to move this one over here, 1, and then 2, and then we'll put, actually, let me draw this a little bit differently. Let's put 1 down here, 1, 2, we'll do 3, 4, 5, and then 6 over here. And I'm going to go ahead, I'm going to erase these guys because I'm going to show you how to actually, how this breaks down and gets all that stuff squared away. So for the first one, because we are 64, because we're going to do the line up here, it's not going to be a line graph where you line up the horizontal and the vertical columns and bam, you're good. Not quite that simple. But what we do is we take the value of 64, so we need to turn this bit on and this bit on, but all these other bits could be turned off. So 0, 0, 0, 0, 0, 0. So 128 and 64, what does that equal out to? So 128 and 64, that actually equals 192. Okay, but now that I know that, I can go ahead and do that for the second range, or for the second subnet. So for the second one, I'm going to turn this one on and this one on, and then all zeros across the board. It's going to be 192. I'll explain how this process is allocated here in just a moment. Then I need to go down to 3. 3 is going to be under 32, so for the third one, I'm going to turn on this bit, and this bit, turn off these bits, which gives me a 224, because 128 and 64 is 192, plus 32 is 224. So for 4 and 5, do the same thing. 1, 1, 1, 0, 0, 0, 0, 0, 2, 2, 4. 1, 1, 1, 0, 0, 0, 0, 0, 2, 2, 4. Now for the last one, I'm going to do 6. That's going to be under 16, so I'm going to do 1, 1, 1, 1, 0, 0, 0, 0, which gives me 224 plus 16, 240. Bam. I've got everything subnetted out that I needed to have. Now, where this value comes into play here is, remember, with this portion right here, we're doing 10.1.1.1, 10.1.1 /24. So our minimum subnet mask out of the gate is going to be a /24. So for the first one, I'm going to come in here and do 255.255.255 dot, and I'm going to take this 192 and park it right here at the very end, 192. What that means is I'm going to have 192 as my subnet mask, which is going to tell me that I have 64 total users. Okay, which means, let me go ahead and finish writing this out and getting that squared away. So 255.255.255.192. Okay, and then for the remainder of them, we're going to do 255.255.255.224. And the same thing here, 255.255.255.224. And then I'm just going to draw it across the board here because we already know what that is. 6 is going to be pretty much the same. 255, 255, 255 dot 240. Okay, now where this comes into play, again, 192 ties to 64, which means my subnet is actually going to be 10.1.1.0, and because we're dealing with /25, /26, because we're taking bits from the host and giving it to network, we're going to move this over. This is going to be, is this /25, this is /26, /27, /28, /29, /30, /31, /32. Because of that, I'm going to go ahead and give it a /26, which means my range, actually, let me back this up a little bit, .0 through 63, and it's going to be /26. Okay, so 10.1.1.1, 255.255.255.192 is my subnet, 0 through 63, because this is also my range of IPs. The next one up is going to be 10.1.1.64 through 127/26. 127 because 64 is 128. Okay? I've got that. Now the next one coming up is going to be 10.1.1. I'm going to start at 128, but instead of doing it in increments of 64, I'm going to do this in increments of 32 now. So in this case here, it's going to be through 32 plus 128. I believe that is, I don't actually have a calculator in front of me. Give me 1 second to pull up a calculator. So let me go ahead and bring this guy over just a touch, and we're going to do 128 plus 32. 160. Okay, so that's 160. Move that off the screen real quick. We'll do 160. This will be 160. Sorry, 160 there /27. Because remember, we've got 1, 2, 3 bits turned on for this guy. Same thing with here. This next one up is going to be 10.1.1.161. I'm sorry, not 160. This will be my mistake. 159/27. This one will be 10.1.1.160 through, and 32 plus 160 is going to be 191. So technically it's 192/27. This one will be 10.1.1.192 through, and 32 would be 223/27. And then this last one here will be 10.1.1. And this will be a 224 through, and because it's a smaller subnet, 240/16, that'll be 239/28. Okay, so that's how it's all subnetted out, right? And that gives me all of the configuration that I need, or I should say that gives me all of the subnets that I need. So that does give me a little bit of wiggle room on the back end. So I technically have another 15 or so, 20 about, or 15-ish subnets that I can, or IP addresses that I can apply in this case in order to make this work. But that's how you break this down. So that's how you take a /24 subnet and then you break it into much smaller subnets. So when you're doing subnetting, you're actually taking a large subnet, a large allocation, and you're breaking it down into smaller subnets. You can do this for class C, so /24s. You can do this for class B /16s. So you can take a /20 address range and you can break it down into multiple smaller subnets as well. Same concept applies. This process up here of taking the high order bit to the low order bit process, as well as the slash notation, and then these bits right here, what they do is they repeat themselves. So if you wanted to do another range in the class B address range, so in this case here it would be to the right, or to the left of the decimal. So we just subnetted in this one, you could subnet in this one as well. And that's basically how that would work. Now, I'm going to go ahead and give you another example of a class B range, just so you guys can see the difference. And we're going to stop there because this video is getting a little bit long, a little longer than I intended it to be. But I think this is good for you guys to see how this process comes into play to break it down the way that it is. So if you guys have any questions up to at any point, leave a comment and I'll try to do my best to answer it. So I'm going to pause the video, I'm going to clear the screen, I'm going to come up with another scenario, and then we're going to walk through how to subnet it down. Now the big difference between the two is when you're doing a class B range versus a class C range. A class C is a single /24 with 256 IPs. You start deducting the network ID, you start deducting the broadcast IP address, so the 255, and you remove one IP as the default gateway. When do you do that, then you're going to have, I'm sorry, before I jump ahead, every one of these is going to have the same process apply. So this right here is going to be the network ID. This right here is going to be the broadcast for that particular subnet. And then one IP from this range, 1 through 62, can be used for the default gateway. 64, this is the network ID. This is your broadcast IP address. And then you can do 65 through 126 are going to be your IPs that you can allocate as your default gateway. This is your network ID. This is your broadcast IP. And you can do 129 through 158 as your default gateway IPs. This is your network ID. This is your broadcast IP. And then you can do 161 through 190 are going to be your default gateway IPs. This is your network ID. This is your broadcast IP. You can do 193 through 222 as your default gateway IP. Here is your network ID. This is your broadcast domain, or a broadcast IP. You can do a 225 through 238 as your default gateway IP. Okay, I'm going to go ahead and clear the screen, and I'm going to pause as we move forward because I need to make this part up here. This needs to grow and actually be shifted to the right so we can bring in the class B range. So I'm going to go ahead and do that and pause. Alright, so it took a little bit, but I was able to get everything laid out the way that I needed it to. So basically what I want to do and help you understand here is we have at the very top, we have the actual subnet mask for all of the subnets on the left side of this line right here. So on the right side will be the /24 or the class C address range. On the left side of the line, we're going to have the class B address range or the second octet. This is going to be the third octet over here. What I've laid out at the top is the 8 bits for the third octet, the 8 bits for the 8 bits for the fourth octet, and the 8 bits for the third octet. I've also laid down the CIDR notation. So when you get down to here, you get /24 through /17. And then as I also laid out is the IPs that are associated to that individual slash notation. So when you go left of the line, you go to much larger subnets. When you, down below that, we have the mask. So the associated subnet mask that will be for that particular octet. So this is the third, this will be the fourth. So when we take a look at something like a large address, like for example, a class B address range, any one of these can be private IP or a public IP can be used in this case. So for example, if you take a look at say 10.1.0.0/16, this right here would be the third octet. This is what you're subnetting with this portion right here, where we already took a look at the portion over here in the previous example. So we're not really going to look over here. We're going to be focusing mainly right here on the third octet. Now, when we take a look at this, the way you look at this value right here is going to be 0 through 255. Okay? So that means you have 0, 1, 2, 3, ... 255. So a total of 256 /24s is what that would equal. And you can break it down to that. So I can come over here and take /10100/16, and I can break that down and do 10.11, 10.12, 10.13, 10.14, so on and so forth. Now let me break down some of these into more specifics. So in terms of summarization or aggregation, if I have a group of addresses, so let's say for example, site 1 gets 10.1.0.0/16, and I allocate, let's actually do this a little bit differently. Let's say instead of, it gets this address range, but we'll just site 1, and then we're going to specify that this guy gets a /20, okay? And then site 2 gets 10.1.0. In this case here, we want to overlap it so that we're going to be using the same range, the same /16, we're going to subnet it. So in this case here, we /20. /20 is right here. So that means we're going to have 4,096 bits, or I'm sorry, IPs that we can allocate at this one site. So we're going to be subnetting this portion right here, just this third octet. The /20 is going to be a total of 16 IPs, or I'm sorry, 16 /24s. So that means that my range is going to be 16. So in the third octet, that means this one here is going to be 16.0/24 or /20. That's how that would come into play. Now, another example would be if we were to take site 3 and take 10.2.0.0/ and let's look at /18, for example. So we have the 18. The 18 correlates to 64, which means my range is 64, which means I'm going to do 10.2.64.0/18, so on and so forth. So whatever your slash notation is, however many IP addresses you need to allocate to a particular subnet is going to be, you're going to have the ability of lining that up right here. So this would be 128/17.32768.128. You can totally take this this graph that I've drawn out here and allocate that to whatever you're doing. This is how I subnet, right? So whenever I'm doing a subnetting project or I have to figure out the subnets or something, this is where I start. It makes it very, very easy to work through the problems, figure out what the subnet ranges are going to be, and then break it out from there. That's how I go about doing this, which makes it very, very easy to work with. So now what I do with this particular example here, let me go ahead and get rid of this one for the moment. What we end up doing with this one right here, and actually let me go ahead and get rid of, actually you know what, I'll let that run. We'll do slash 20, but the way this one's going to work here, I'm going to break it out. So we'll do 10.1.0.0 slash 20, and then we're going to do, so this will actually break down, the slash 20 won't be there, we'll do slash 24, because that's what it's going to break down to. We're going to have dot 1, dot 2, dot 3, dot 4, dot 5, dot 15. Now the way this is going to work, this will be all zeros all the way down, slash 24s all the way down, so on and so forth. Okay, that's how that process comes into play. Because when you break up a slash 20, you automatically correlate it to whatever the bit range is on top. That's going to be your range, and then you're going to be able to determine how many subnets, how many slash 24s you're going to be able to allocate. Now, the way that I also want to help you guys understand this is when you're taking a look at this, if you want to take a couple of slash 24s and you want to summarize them, come up with a large address block, and you want to, I should say not, yeah, summarize it in order to take multiple individual subnets and advertise them as a single advertisement instead of advertising 10.1.1.0 and 10.1.0.0 slash 24, you can advertise this as 10.1.0.0 slash 23, because slash 23 is 2 slash 24s, and a slash 22 is 4 slash 24s, a slash 21 is 8 slash 24s, a slash 20 is 16 slash 24s, so on and so forth. And it continues to grow. Now, if I allocate a slash 23, that means that I'm actually going to be having 2 slash 24s, right? Now, the way that this works is you have 10.1.0.0 slash 24, which is in this octet, you have 0 through 255, right? If I go 10.1.1.0 slash 24, and this one here, I also have 0 through 255. Okay, with that understanding in play, we can then take a look at, if we're not going to break this down into 2 slash 24s, it's a single address, right? We're going to just apply this to everybody. Would this guy and this guy be able to talk to each other? The answer in this case here would be yes, they would. But you're like, but wait a minute, Rob, the binary ANDing that you talked about in an earlier example, the IP addressing doesn't work. In this case here it would, because the subnet mask would allow it to. Because where the subnet mask is going to come into play, for example here in this octet right here and in this octet right here, when we're looking at a slash 23, we're looking at 255.255.254.0, okay? Which means everything up to this last bit here, this last couple bits, need to match. So in this case here, when I'm looking at this is okay, because this technically is one big subnet. I'm looking at 2 individual slash 24s, but because the fact when you break this down here, let's actually draw this out. When you look at a 255 and a 254 subnet mask, or bit notation here in the third octet, you're looking at 11111111, right? When you're looking at 254, you're looking at 11111110. So because of the fact that we're looking at this for this guy here and this guy here in the third octet, that means that we're not matching up to the very last bit. So 0 and 1 are technically, this guy right here is the second bit, or it is the last bit. So it's actually able to be done. So The idea is when I take this IP address right here and this IP address right here, yes, they are 1 bit apart, but when I take 10.1.0, which is the network, which is the lowest subnet, I take 10.1.1, and I take those together, they're 1 bit different. This is 1 bit different right here. 1 bit different. It's enough of a difference to allow a /23 to allow communication between two /24s. The two /24s technically don't even exist, right? You don't even look at it that way. You look at it as, from an IP addressing perspective, you look at it as 10.1.0.0 through 10.1.1.255. That's how you view a /23. And I know it's obvious that in the third octet here, right here and right here, there's a difference, right? That doesn't affect us here because the bit capabilities eliminate that, and that's the important thing that I want you guys to understand and remember here. Because that goes away, that gives us the ability of using this 2 different /24 address ranges. The same thing would go for if I was using a /22. So let's take this one a step further. A /22 is 4 /24s, which means my range is going to be 4. So if I was to take 10.1.0.0 through 10.1.3.255, this is a /22. It's 4 /24s, 0, 1, 2, and 3 respectively. But because of the fact that the subnet mask that I'm associating to it takes the binary ANDing that would normally not work in the third octet here, it allows it to happen here. And that's where that factor comes into play. This is something that a lot of people just getting into the IT industry and the networking space, they struggle with because they don't understand. /24s are pretty easy to understand, but when you start taking it into larger address ranges, /22, /20s, etc., that's when this becomes more complicated. We'll talk more about summarization when we get into dynamic routing, because that's something that we're going to be able to, instead of advertising a bunch of individual /24s, we can advertise one single large advertisement and get the job done that way too. So that's what I really wanted to lay out in this video. Yeah, it's a little bit longer than I wanted to go, but I think this is really good information for you guys to understand in terms of the operations. So with that being said, I want to thank you guys for hanging out with me in this video. If you have any questions, again, please, the green screen is giving me a hard time here. Please leave a comment in the comment section below. Please like, share, and subscribe, and I'll catch all of you in the next video.